Hey guys, and welcome to another session in the Mind Grid. Today we are talking about MyHDL, the tool that takes you from Python to Silicon. And you can design hardware with Python. MyHDL turns Python into hardware description language, verification languages, etc. Today we'll do an example of it, and we'll see how counter in Python can be turned into a counter in Verilog. So without delay, let's look into it. So let's do a view of counter.py. In this counter.py, we can see that we have first imported everything, all the various features of MyHDL, which we'll use to define our counter. Then we declare counter with 3 signals, clock reset, and an output. And then you see a pretty cool feature of this, that when we're declaring count, which is an internal variable, we can use the length of queue, which is defined externally, maybe in a test bench, maybe in an instantiation. Queue is passed from outside, and we can use the length of queue almost like a parameter. And then we can declare a bit vector using that length of queue, and count is an internal signal. Then we have a sequential block, and it's defined like this. We do a process called do count, and then count will just increment count plus 1. Now you see that assignment for procedural or combinatorial both can be done using this method, that count.next. So .next gives you that assignment that will produce what we are used to in Verilog. Either blocking or non-blocking can be achieved. If you're in a sequential block, this is a blocking assignment, and a combinatorial block, this is a non-blocking assignment. So that's what we do. We get this, and then we return. So return is possible through two methods. One is you can just call return instances, or you can specifically define what we are outputting. So you can do either one, but I've chosen to do this one because just to be explicit. So there's two instances here, make output process and the do count process. I have to return both of those, and that's how you define this counter. And then in the instance, we just define the signal for clock reset and queue with specific bit vectors. Like I said before, this is parameterizable because queue's width is not defined. It is just taking whatever the width is coming from outside. You could use this counter to instantiate an 8-bit, 16-bit, whatever counters. So then we go into MyHDL Verilog, and there we say to Verilog and this count instance. Again, it's possible to do this different ways, but I've done a very simple way, which is to Verilog count instance. Count instance was the instantiation of the counter. And then when we come to Python, we just say Python3 counter.py, and you will get two blocks. One of them is counter.v. And this counter.v, you can see that it's generated the Verilog module, the usual clock reset queue, declared all the inputs, outputs, and then when reset, count is 0 and count is count plus 1, and then it assigns queue. This is exactly as the Python module was defined. Very simple to convert it. And then just to see if it compiles, we can just do Icarus Verilog counter.v, and you can see that it compiled. So overall, this is a quick take video, and we can show that we have taken a simple module in Python, converted it into Verilog, and that's fairly simple to do. Now, as the modules get more and more complex, this might get more interesting and maybe nuanced. There may be some bugs, but at least it gives you a starting point to actually model the code in Python quickly, and then convert that into Verilog, and then just start to integrate into your other projects. So hope you liked it, guys. If you did, give me a thumbs up or subscribe to my channel if you have not, and I'll catch you in another video. Until then, take care and bye-bye.